Hi everyone, welcome to this episode of Keipert Labs. In this video we're going to discuss the concept of motion graphs, specifically focusing on distance versus time graphs. So far in our physics topic we've been looking at the idea of how we can measure and describe motion. And we've been talking about it in terms of ideas like distance, speed or velocity and time as things that we can measure. And so we've been practicing making graphs of measurements that we've made of one variable versus another. But now we want to actually see, all right, well, how can we describe the motion of an object using a graph of its distance or its position versus time? Okay, and so we're going to go through kind of what these sort of graphs look like and then some different scenarios that we're going to work with. Okay, so you've got a sheet that you can work with this one. Okay, and so this is kind of, I'm going to talk you through this so that then you can add these to your sheet. Okay, so these are the sort of axes that we will be using. Okay, so we've got time is always on the x-axis when we're thinking here, because we're looking at it as a line graph as opposed to like a scatter graph of one variable against another. So we're kind of tracking a change in an object's position over time. You know, so we might be looking at after 1 second, 2, 3, 4, 5, and so on. Okay, now in this case, on the y-axis of our graph, we're going to be looking at measurements of distance. Okay, so we'll measure this in seconds. We'll look at distances in meters and kind of go from there. 1, 2, 3, 4, 5. And now you don't have to draw in these kind of numbers on the scales that you've got there. At the moment, we're just on there. We're just looking fairly qualitatively, but I want to kind of set this up so that I can talk you through some of the ideas. Okay, so we're going to look through a couple of different scenarios of an object's motion and what a graph of its distance versus time might look like. Okay, and so that you can add these lines on your sheet. Okay, so the first scenario that we're going to look at is when we have an object that we say is at rest. Okay, now at rest is the same as stationary. Okay, and that is not moving. It is at a particular position, remaining still. It's zero velocity. Okay, and so when we have that situation, let's see. Yeah, we'll go with that for a bit of contrast. Okay, so when we have something that's at rest, it's going to be a horizontal line at 0. Okay. So now I don't have access to a ruler at the moment, but in that sense so that you can use a straight line tool to draw that at the bottom there. Okay, so when we're stationary, we'll see a horizontal line at distance of 0. Okay, so yeah, so we're seeing that we've got a horizontal line at a distance of 0. Okay, so now we're going to look at and say, right, well, let's say we've got an object that's moving at let's say we've got an object that's moving at a constant velocity. Okay, so what we would have there is that it's going to be covering, so for every second that it travels, it's going to be covering the same distance. Okay, so depending on exactly what its velocity would be. Okay, so let's say we've got a constant velocity going like this. Okay, so we have a straight line. Now it's not horizontal. Okay, so we have a straight line, so it's not horizontal. Okay, and so what we can do is we can kind of look at that sort of a line, and we say, all right, well, so that's something that's going at constant velocity. So for every second that it's traveling, that then it's going a consistent change in its distance. Okay, maybe it's going half a meter further for every second that it travels. But let's say we had a situation where we had another object that was moving at a constant velocity, but it was moving faster. Okay, so what we can see is that, alright, so that means that it's covering more distance in the same amount of time. So if this one, say, is covering half a meter, let's say maybe this one was covering a meter of distance in every second that it's traveling. Okay, so we could kind of plot the points of its position if we wanted to, and so then what we're seeing here, if we draw this as a straight line, okay, now that one should be more up here, but that's just my rubbish sort of scale. Okay, so what we see here is that we end up with also with a straight line, but it's got a different slope. So what we can say is that for the constant velocity, a faster moving object gives us a steeper slope of this line. So the slope, or how the angle that it's going up, how fast that the steepness of that line tells us about the speed of that object. So if you could imagine, let's think of a third object that was going slower than the original one. You know, so maybe for every second it's kind of covering 1/4 of a meter. Okay, so we kind of get to 1 meter by the time we get to 4 seconds, and so on. So what we can see here, you know, if we're kind of following that sort of track, that we're also getting it. So we've got 3 straight lines here of varying slope, varying steepness, that relates to their speed. Okay, so the slope relates to, or connects to, the actual velocity of the object, how fast it's traveling. Okay, so that's a key kind of idea. Now what we can do is that we can actually look at a graph and we can measure its slope, and we can actually quantify, if we graph if we graph that motion, that we can quantify its velocity that way, aside from just doing any calculations like we've been learning about. Okay, now let's say we've got now here's kind of another one that you can add on to the previous sort of graph. Let's look at, say we have constant velocity, but we're talking about opposite direction. Okay, so if we had an object that was starting, you know, on the left and making its way to the right, then we can say, well, what about if we were starting at a certain point on the right and moving our way to the left? Let's say we were starting up here, 6 meters from kind of where we would set the starting point, and that over time that we're actually going back like this. Okay, so what you can see is that we have a straight line with what we would say is a negative or downhill slope. So whether the slope is uphill or downhill, that is whether it's positive or negative, tells us about which direction the object's going in, just like we've talked about positive and negative referring to direction before. Okay, so the last example that we're going to go through here, the last scenario that we're going to kind of tackle, is this idea of an object that its velocity is changing, or that is, it's accelerating. That is, velocity is changing. Okay, so that's kind of a key sort of concept that we want to reinforce here. So this idea that, alright, so if it's starting at 0 seconds, you know, so maybe in the first second, it's so it's accelerating at 0.5 meters per second. That is meters per second squared. So that is, for every second that it's accelerating, it gets 0.5 meters per second faster. So after 1 second, it's traveling at 0.5. Okay, after 2 seconds, so then our slope, so then we're getting, so that we've covered kind of a greater amount of distance. And so then what we're seeing here is that then over time, our line is not straight, but actually curves. Okay, so we get a curved line, okay, that indicates the changing slope. Okay, so when we said that the slope of the line relates to how fast it's going, as it's getting faster and faster, that line should be getting steeper and steeper. So that if you're joining these points, that the line joining those points gets steeper and steeper and steeper as you get further along, as it continues to speed up. Okay, or we might also see a curved line curving the other way, perhaps like this. if we're getting negative acceleration. That is, it's slowing down. So that is, as time goes on, it's covering less and less kind of distance for every second that it's traveling. Okay? So they're the sort of scenarios that we can be familiar with for a distance versus time graph when we're looking at measuring motion. Looking at an object that's stationary, that is, it's got a zero velocity, looking at constant velocity, and seeing a straight line where the slope tells us useful information about how fast, and then looking at accelerating objects where we actually get a curved line that relates to the change in the velocity. Okay, thanks very much for watching. Bye for now.